In the last video, I talked about calculating arc length, and we derived a formula for calculating arc length when the angle was given in radians. In this video, I'd like to do the same thing with the area of a sector. So if we were working in degrees, then what we would do is we would take theta over 360, because we know the angles around a point sum to 360, so this is the fraction of the circle that we're interested in if we want to find the green shaded area here, and then we just multiply this by the area of the whole circle, which you know is pi r squared. If we're working in radians, it's going to be exactly the same, but we just need to be a bit careful, because we know that now we have theta radians, so we need to make sure we are talking about the angles around a point when measured in radians, and the angles around a point when measured in radians sum to 2 pi radians. So we have theta over 2 pi radians, that is the fraction of the circle we want, and we multiply that by the area of the whole circle. And this gives us a formula we can simplify slightly, because we can see a factor of pi cancels, so we can cancel a factor of pi, and we get the formula theta r squared over 2, which you may also see written as a half theta r squared. So we know the area of a sector is equal to a half r squared theta, or theta r squared, when theta is in radians. And let's just try and apply this to an example. So let's say that we want to calculate the area of this sector shaded red here. Well, what do we need to know? Well, we know that the radius is equal to 8 units. I've not said whether this is centimetres or metres, so it's just 8 units. And we know that in radians, the angle is pi over 2. So using our formula, the area of the sector is a half times by r squared, which is 8 squared, times by theta, which is pi over 2. And if we just calculate that, we get a half times 64 times pi over 2, which is 64 pi over 4, which is 16 pi square units.